Hello and welcome. In this video, we're going to be discussing how we can implement a two-way ANOVA analysis using R. One of the first things we have to talk about, though, is how we're going to enter the data into R. So if you want to, you can go on and skip ahead and see the commands I do and just kind of copy and paste them if you want to, or you can just type it in your own way. But if you want to hear the logic of what I'm thinking through, maybe this first part's going to be helpful. So for the two-way ANOVA data as it was provided to us in the notes, you'll note that we had 2 rows and 3 columns, and in each cell where they met, we had 5 observations. Well, there's a few different ways we could approach this. We could enter 5 observations going across. So if we're entering this as a matrix form, 15 total observations, 5 for the first column, 5 for the second column, 5 for the third. But there's no reason to say that. I mean, eventually we're going to want to go in the long format anyway. The approach I'm going to take, I think, is I'm going to start with the 3 columns, and I'm going to write out all of the numbers in each of the columns, and then I'm going to stretch out that middle row labels to be repeated so that when I write out, say, the first 5 observations in the D column and then the second 5 observations in the D column, the first 5 will be labeled with their appropriate metal, A for alkaline, and B, the second 5 will be labeled with their appropriate metal, L for lithium. So that's the approach I'm going to take when I'm entering the data into R. What this will do, incidentally, is give me a mixed data set. It'll be a data set that's both long and wide at the same time. It'll be long in terms of the metal entry, but it'll be wide in terms of the brand. Believe it or not, R and the command we already used, pivot longer, can handle that type of data and can pivot it. Again, you can take different approaches to entering this type of data. Once we get to 2 and more variable data, they can be a little complex. I prefer to just have it entered in long format anyway, but oftentimes when I'm working on problems, that's not always the case. Remember, depending on your software, you may or may not need to do this, though I will say most softwares do require manipulation of data prior to being able to be analyzed. So understanding how to go between long and wide format data is kind of important no matter where you end up. For your homework, consider just entering it in the long form anyway. That is, a column for each variable, including a column for the numeric value, and then you'll just write out for each number what is its first categorical variable level, what is its second categorical variable level, and what's the number, and you'll do that for each number. That'll see you right through your homework if you want to. But in this example, I'll enter it in a way that's a little more convenient for me, and then we'll talk about how we can pivot something that's in a mixed format to be in a purely long format. All right, well, let's get started. So I'm starting with a blank slate here, and I'm going to need to enter my data. Again, feel free to pause. You can pause, you can fast forward, you can rewind if you want, but you could fast forward to when I have all this entered, and then you can just go on and type all this in yourself. Again, all I'm doing is I'm going to the data set from our notes, and I'm glancing at that here, and I'm writing out all of the different numbers from there. Now I'll say, I hope I don't have a typo in this video, but if I do, I'm certainly not going to know it. So my numbers may or may not match. In that case, you're welcome to come back and check out the numbers I ended up typing in if you want to see. Now I'll say I'll do a bit of error checking here. I'll use the length command to make sure I typed in 10 values. Remember, I'm in the D column. I have 5 values for alkaline, 5 values for lithium. And so I want to make sure that I'm typing this in such that all 10 of those values, 5 for each metal, are appearing in that D column. I mentioned you can hand count these things, but what I'm doing right now is trying to error check in case I did it by hand wrong. And so using built-in commands can be helpful for that. I have a few friends who work full-time in industry, and one of the things that they recommend is being able to just have an idea of what you expected so that you can do some basic error checking. In my case, I expected 10 values, and so I can error check compared to 10 values. But if you didn't even know what you were looking for, you wouldn't be able to check that in the first place. I'm going to hit the up arrow that accesses the previous command. I'll hit it again to access the one even before that. And then I'll just replace that D with an E to, again, run that same error check. And this isn't perfect, but it does tell me at least I'm getting the right number of numbers listed. I didn't accidentally have a typo and forget one completely. So maybe that wouldn't be a typo if I forgot one completely. That would just be missing one completely. 67, 67, 71, 73. All right, and again, up, backspace G. I forgot my parentheses. If you ever run into this case, by the way, this can be really irritating to get out of. In R, I actually remember the first semester I used R in graduate school. I couldn't figure out how to get out of it, so I'd like close RStudio and reopen it. If you just hit the escape key, that gets you out of that. I'll hit the up arrow to see that again, and then I'll do the close parentheses. You can also, in that case, just type the close parentheses and hit enter again. It's simply saying that it's waiting for something for you when it gives you that sign. In any case, I have all 10 things entered for G, so that's good. All right, so now I've got it all listed out, but now I need to list out the metals. So these first 5 observations are metal A for D, E, and G, and the second 5 are metal L for D, E, and G. So I need to repeat A 1, 2, 3, 4, 5 times, and then I need to type L and have that repeated 5 times as well. Now you can do this in a couple of different ways. The way that I'm going to do it is by using the REP command. So REP, remember, repeats things. We have used this in a previous video. So I'll repeat A 5 times, and if I run that line, you'll see that A repeats 5 times. I'll copy and paste this and then do repeating L, and then I actually want to concatenate all these results together. So repeat L 5 times as well. Again, just copying and pasting, putting it in a concatenate separated by a comma, and that gives me a list. Oop, looks like I'm forgetting a parentheses somewhere. Go to my code, add a parentheses at the end to end that concatenate open parentheses. I repeat A 5 times, and then I repeat L 5 times, and I combine them all together to give me one long column. I'll call that column metal, and that'll be something that I'll enter here. And so now I can put all of this together. I'll tell it TWDAT for the two-way data set. I'll do a data frame with metal, D, E, and G, just like it was presented in the notes, and I'll look at it. You'll see that instead of the values being presented sideways like they were in the notes, I am listing them all in a column form for D, E, and G. And now I'm just adding metal, repeating those metals the appropriate amount to correctly indicate which metal is associated with which value. Again, this is a slight reformat of that data. This is now long in the metal form, but not in the brand form. To make it long in the brand form, I'm going to use that pivot _ longer command. But actually, I'm noticing right now in my environment, pivot longer comes from a package that I haven't loaded. So if I ran the pivot longer command, it's going to tell me that it doesn't know what package it comes from. We can even try this here just to show you what the error looks like. Pivot longer. It's going to say, could not find this function pivot longer. It doesn't exist. Well, it's not that your computer suddenly you're in a new dimension, the Twilight Zone. All this is saying is, look, pivot longer is from a particular package, and you haven't loaded that package yet. So I'm going to do the library tidyr command to load all of the functions from the tidyr package, and then I'm going to do the pivot longer command. For pivot longer, I give it my data set. Right now it's the TWDAT, the two-way DAT data set. And then I need to tell it the columns that I want to pivot. Remember, previously this was all of the columns, but right now metal is already written in long form, so I don't want to pivot on metal. I just want to pivot on D, E, and G. So I'm going to do D through G. These are the ones that I want to go from wide to long form. Again, metal's already in long form, so I don't want to do anything with that. It's the D, E, and G, the brand categorical variable. That's the one that's in wide form right now, and that's the one that I want to pivot longer. Now, as before, I give it the names to argument. So this is just asking, where do I want those column names to go to? I want those column names to go to a new variable called brand. Where do I want my values to go to? I want those values to go to a new variable called hours, and I'll run this to see what this looks like. Now I'll say this comes out as a tibble, not a formal data frame. A tibble is just a fancy data frame that some of the packages in R use. One of the characteristics of a tibble, though, is it doesn't just display all of my data. It only displays the first few rows, but it does give me a little informational item that there are 20 more rows, as well as providing the full dimensions of the data set here. There's 30 observations. I'll go on and save this because, again, this isn't saved anywhere as any variables yet. I guess I'll call this factdat, fac, for my factorial ANOVA data. Remember factorial ANOVA, just ANOVA with more than 2 variables. And then if I wanted to see this, I could do data frame factdat. What data frame does is it turns it back into a true data frame. It doesn't have that thing where it cuts off the rows, and I can see all the rows. Again, this doesn't really cut off the rows. Information is still saved. It just doesn't print it. This is really nice if you have data frames with hundreds or even thousands of observations, that it doesn't print all of them for you. But with ours, maybe we want to see what the long version of this data look like. And this is what the long version of this data look like. I can go and manually double check a few of these values. Again, I tend to manually check at the end and the beginning. And so if I look at the first few, and this reads across, it goes across before it goes down, kind of like the reading order, left to right, top to down. So 67, 76, 76, all of those are metal A, D, E, and G, 67, 76, 76, brand D, brand E, brand G. These 3 rows correspond to these 3 observations in these 3 columns in the first row. And so that's converting correctly. The last 3 are all metal L and should be brand D, E, G with a number of hours 70, 83, and 73. So I go to the last 3, 70, 83, 73, brand D, E, G, all from metal L. So this appears to be reading incorrectly. Again, I check the first few, the last few, just to make sure that all of the numbers are being read. And then with the first few, I make sure that the pattern is being read correctly. All right, well, now that I have my long data, I'm going to be ready to go on and fit my ANOVA model. So I'm still going to use the AOV command. I provide the dependent variable, hours, first, and then that squiggle, and then I provide the independent variable. What's interesting here is that the independent variable, there's actually 2 independent variables, metal and brand. So if I want to do this, I would type, let's say, brand times metal. Now I'll say in R, the times asks R to give me the main effective brand, the main effective metal, and then the interaction between the 2. So in this case, main effect brand, main effect metal, and then also include the interaction. I would put a star there. You can also use the plus sign. The plus sign says, just give me the main effective brand and main effective metal with no interaction term. So if you were doing, say, one of the randomized complete block designs where we don't use the interaction term, you would put a plus there instead of a star so that R would not calculate the interaction as well. But for us, in a two-way ANOVA, we do tend to include the interaction terms. Last but not least, I need the data command, and the data that I want to pull these variables from is the factdat data set. Note, as before, the regular AOV output is not particularly useful. I'll save it as a new variable called facmod. Now, whenever I type facmod on the right, it has all that information stored, and then I'll use the summary of that data set facmod, or excuse me, the summary of that model. And this gives me my more traditional two-way ANOVA table. Recall our interaction term is the thing we look at first. In R, the interaction term is denoted with a colon, so brand colon metal indicates the interaction between brand and metal. Recall what interaction meant. Interaction meant that the effect of the brand on the number of hours that a battery lasts depends on the metal. The brand effect isn't consistent. For some metals, it's bigger. For some metals, it's smaller. Or for some metals, brand A is better. For some metals, brand B is better. All of that are potential implications of a significant interaction term. A not significant interaction term essentially means that for brand and metal, the brand effect on battery life doesn't depend on the metal. The brands are consistent across metals, or there's not evidence that they're not consistent. So in that case, I would just interpret my brands and metals appropriately. And all my interpretations, of course, for the main effects are after accounting for the other variable. In my workflow, again, I first interpret this interaction. If the interaction is significant, I'd stop, and then I'd create an interaction plot, which we won't show in this R session. We'll talk maybe a little bit about that later on in the course. But for ANOVA, we'll just leave it and say, yeah, we need to do the interaction plot. You can Google how to create interaction plots. They're not particularly difficult in R, but it's not something we'll worry about because it's not going to be something to make or break us here. So yeah, for here, the first step, interpreting the interaction. So I look at this interaction, look at the p-value. The p-value is bigger than alpha. So in this case, I fail to reject the null. That is, I don't have enough evidence to determine that there's a significant interaction effect. Because there's no interaction effect, or not enough evidence to determine that there's an interaction effect, I go on and I interpret my main effects for brand and metal. Again, I do tend to check the degrees of freedom. I have 3 brands, and this is the number of brands -1 for the degrees of freedom. 2 degrees of freedom, that looks right. I have 2 metals, 2 minus 1 equals 1 degree of freedom, that also looks right. So this looks like these are being read incorrectly. If that ever doesn't line up, I would go back and check and make sure your stuff is in quotation marks to make sure that's being read incorrectly. Sometimes that happens, that you didn't put in your categorical variable in quotation marks. So it reads as a number weirdly. That's like if you have group 1, group 2, group 3, that might happen. All right, so now that I can just interpret my main effects, brand, I see that there is, and you can see the stars here, which indicates statistically significant. This number, e to the -7, indicates that the decimal goes to the left 7 places with a bunch of leading zeros. This is a very small number, so this is certainly below my alpha level of 0.05. So there is enough evidence to conclude that there's a statistically significant difference between the brands. There's enough evidence to conclude that the brands have different battery lives, or that there's a significant effect of brand. Note that those conclusions are all after accounting for the other variable. So when I say that, I can say there's a statistically significant difference between the brands' battery lives after accounting for the metal that was used to create the battery. In the metal interpretation, P is a large number, greater than alpha, so there's not enough evidence to determine that metal has an impact. There's not enough evidence to determine that the metals have a statistically significantly different battery life after accounting for the brand. So again, we do the interpretation, and the interpretation is after accounting for the other variable. All right, well, that's the end here. I will add one more fun thing. I'm going to go on and load the Desk Tools package. Remember, I already downloaded it to my computer, so I can just use the library command. This is how to do post hoc tests on Way ANOVA. We didn't talk about it on the lecture. It's not going to be on your homework. It's not going to be on your exam. But this is something that's just kind of handy to know how to do. I do the same post hoc test command, and I give it my factorial model. But by default, it's going to provide me all of the post hoc tests. Whereas in this case, I don't really need all the post hoc tests. Remember, we only do post hoc tests when we have a statistically significant effect. And in this case, only brand has a significant effect. I'll say in general, with 2- and 3-way ANOVAs, I tend to not do post hoc tests with interaction effects. I'd rather look at the interaction plot to interpret those if those are significant. So for me, post hoc tests for 2 or more way ANOVA only enter the picture when my interaction effects are non-significant. If they were significant, I'd be looking at the interaction plot. So when interaction effects are non-significant, now I'm looking at the post hoc test, and I'm only looking at it for the main effects that are statistically significant. In this case, I'm only looking at it for brand. Metal wasn't significant, so I know that there's not a significant difference between the brands of metal. I don't need to investigate which brands are significantly different because none are. There's no evidence that any of them are. How do I just pull the effective brand though? Well, in the post hoc test, I can use the which argument, and then I give it a list of all of the main effects that I want. In this case, there's only one, brand. I'll include it in quotation marks, and this will go on and pull up the post hoc tests for the battery brand. You can see that the information looks identical to our previous information on post hoc tests. And you'll note I didn't include a method. The default method that it does is Tukey's HSD, which is a perfect method for pairwise comparisons. All right, well, that wraps up our video for today. In today's video, we started with data entry and talked about how we can do some manipulation of data entry. We talked about entering data in a convenient format for us to type in, recognizing that that format was both a mix of wide and long data, and how to use R to convert that mix of long and wide format data to a true long format data set. After that, we talked about how we can implement a two-way ANOVA using R, and how we do a little bit of the interpretation. Finally, we closed with a little bonus. That was how to do the post hoc test in R, something that's not in our lecture videos. And again, it's not going to appear in any homework or exams, but it's kind of fun and useful to know if you're ever actually doing this and want to figure out, hey, if the brands are significantly different, which brand is better, if any. All right. Well, team, thanks for sticking with me. And this wraps up our coverage of ANOVA for this course. We'll be using a little bit of it later on. But yeah, this is the end of that main chapter. So again, thanks for sticking with me. And I'll look forward to catching y'all in the next video.